solve a tax rate or interest rate problem using systems. So I want to start with a similar setup. The first column will be either the cost of the principal, the cost of something, or how much money you're starting with. The second column will be interest, and then the third column will be if you're saving money, it's the interest earned, or if you bought something and you're getting charged interest on payments, it's the finance charge. Similar thing with when we're talking about a tax problem. You have your original amount, your tax, and then your tax paid. And also the both bottoms a little different from last section. We have our totals down there. Let's take a look at a problem. I'll give you time to look at this. Dale bought a desktop computer, a laptop computer before finance charges. The laptop cost $450 less than the desktop. He paid for the computers using two different financing plans. For the desktop, the interest rate was 7% per year. For the laptop, it was 5.5% per year. The total finance charges for 1 year was $279. How much did each computer cost before finance charge? So this is your interest rate. It's a finance charge. So number one, we have the cost, the interest rate. I didn't put rate in the previous picture, and we can put finance charge. So we have this. So we have a desktop and a laptop. And down here we'll need possibly a total of some sort. Okay, let's go back to the question. What are they asking us for? How much did each computer cost before financing charge? All right, so we're looking for that original costs. So the original cost, I'm going to call desktop my X, laptop my Y. Okay, the interest rate for the desktop was 7, the laptop 5.5. So 7%, 5.5%, but we have to change those to decimals. Okay, so the finance charge is the cost times the interest. So here we have 0.07x, and here we have 0.055y. So there must be some other information here. The total finance charge for 1 year was $279. So the total finance charge here was $279. So we can write 0.07x plus 0.055y equals 279. That was our total finance charge. And then I think there's a comparison of value. Before the finance charge, the laptop cost $450 less than the desktop. Okay, so the laptop costs $450 less than the desktop. So y equals x minus 450. Okay, so the laptop, which is y, costs $450 less than the desktop. So we really don't need a system here. To be honest with you, you can just put this x minus 450 in for here and just solve it out. Okay, what I'm going to do is, Alex says you can use a graphing calculator. You have to solve this for y. It gets a little messy. I would just plug this in for y, do a substitution. So 0.07x plus 0.055 times x minus 450 equals 279. So I just plug this in for this. Okay, so I'm going to solve that. So when you distribute 0.07x plus 0.055x is 0.125x. We have a minus 0.055 times 450, which is 2475. Equals 279. Okay, so take our 279, add the 24.75, and then divide by the 0.125. And x is 2,430. To find y, just plug it into here. So 2,430 minus 450 is 1,980. If you want to solve both these for y, put them in the calculator, that is fine. But you're going to get very big numbers, so they're going to be quite a bit off the screen. I think just doing a substitution because you already had a 1y equal is a way to go. Okay, number 2. Last year, Dion had $30,000 to invest. He invested some in the account that paid 7% simple interest per year, and he invested the rest in an account that paid 9% simple interest per year. After 1 year, he received a total of $2,440 in interest. How much did he invest in each account? So we're making money on an interest rate here. So we're going to go the principal, how much money we started with, the interest rate, and then here is the interest earned. Okay, so we have two accounts. We have one account pays 7%, one account pays 9%. And the question is, how much did he invest in each account? So the question is, how much did he invest in each account? How many accounts are there? There are two accounts. So we're going to go account 1, account 2, and we'll go the X and Y. Oops. Okay, so this is 0.07x, this is 0.09y. And down here we're going to put our total. Well, we know oops, sorry, that's 0.0x, I got ahead of myself. 0.07x, and this is 0.09y. So it's principal times interest is how much you earn for that year. Principal times interest is how much you earn for that year. Now total. In the problem we're given, we invested $30,000. So our total of what we invested is $30,000, and the interest we made for the year was $2,440. So that's the amount of money we made. So that's going to go over here. Okay, so we can just add down. So x plus y equals 30,000, and 0.07x plus 0.09y equals 2,440. So our total amount of money we put in is this, and here is the interest rate that we earned. So this plus this equals this plus this equals that. Now here, I think I'm going to use substitution. I don't really want to use a graphing calculator here. So I'm going to just solve this one for y. Y equals 30,000 minus x. And I'm going to plug that in for y here. Could you have solved for x there? Of course. You get the same answer, just the opposite order. You'll find your x first instead of your y. Alright, so 0.07x plus 0.09 times 30,000 minus x equals 2,440. Going to multiply it. So I'm going to do the 0.07 minus 0.09x. So we get negative 0.02x, and 0.09 times 30,000. 2,700. Okay, we're going to solve this. We're going to do 2,440 minus 2,700. And then we're going to divide by the negative 0.02. And we get, for x, we ended up with 13,000. So I subtracted 2,700 from both sides, divided by negative 0.02. Alright, so if x is 13,000, 30,000 minus 13,000, y is 17,000. So in account 1, we have 13,000. In account 2, is y, we have 17,000. Like I said, if you solved this for x and plugged in, you would have found the 17,000 first and then the 13,000. So it doesn't matter. And here's from Alex. I just explained all that to you. See, they said just use the graphing calculator, but that means you have to solve this for y, which is pretty easy, and solve this for y, which is kind of ugly. You could do it that way, but then these numbers are big, so they might be off the screen, especially with the TI. I'm not sure how the Alex calculator works. Okay, so this problem is a tax problem, number 3. Same setup. If you want, you can pause it and try it. Theater group made an appearance in 2 cities. The hotel charge before tax in the second city was $1,500 higher than in the first. The tax of the first city was 6%, and the tax of the second was 8.5%. The hotel tax paid for the 2 cities was $598.75. How much was the hotel charge in each city? All right, so we have our charge, we have the interest rate, and then the interest paid, which is kind of a different concept. Usually we look at that, usually we add the interest paid to the charge and just figure out the whole charge. Okay, so we have 2 cities. We have Hotel 1 and we have Hotel 2. Hotel in City 1, Hotel in City 2. Okay, they want to know how much did the hotel charge in each city before tax. So under the charge, we're putting X and Y. And in our first hotel charge for the tax in the second city was $1,500 higher than the first. We'll use that after. The tax in the first city was 6%. The tax in the second city was 8.5%. So this is 0.06, this is 0.085. So the interest paid, or this is really a tax. I was like interest paid tax. So the tax paid is 0.06x. This is 0.085y. Now they give us some totals. Hotel tax paid for the two cities was $598.75. So the tax we paid for the two hotels was $598.75. So we know we have 0.06x plus 0.085y equals 598.75. And then they told us there is a comparison here. The hotel charge before tax in the second city was $1,500 higher than the first. So the second city was Y, was $1,500 more than the first. So it's the first plus $1,500 or $1,500 plus X. Doesn't matter which way you write it. So technically, you could have put that here and not really use and shortcutted this a little bit. So this is going for Y, 0.06x plus 0.085 times x plus 1,500 equals 598.75. So if I distribute the 0.085 times the x, I get 0.085. So I'm going to add these together. So I'm going to go 0.06 plus 0.085. I get 0.145x plus 0.085 times 1,500 is 127.50 equals 598.75. So we're going to subtract its 127.50 from both sides. So 598.75 minus 127.50, which is 471.25, and divide that by 0.145. X equals 3,250. And then we know Y was $1,500 more, so we get 3,250 plus 1,500 is 4,750. So those are the costs of the two hotels. So this is hotel at City 1, hotel at City 2. Is that one. So that's how you set up and complete these problems. This completes this lesson.